In this question number 24, a solid aluminum sphere of diameter d is losing heat by convection and as well as by radiation to the ambient, and emissivity of the sphere is epsilon. That ambient temperature you may take it as T infinity. Taking the emissivity of the aluminum as epsilon and density as rho and Cp, rho and C for the aluminum sphere, the rate of variation of the sphere temperature with the time during cooling process. The simple energy balance for the sphere says that energy balance for sphere at any instant of time t seconds is, from the moment the sphere is exposed to this surroundings, it keeps on losing heat by convection and as well as by radiation. There are two different modes of heat transfer taking place simultaneously. One side convection, another side radiation to the ambient. The temperature of the sphere at any instant, if you take this as T, we need to calculate what is the dt by dt at any instant of time. What is the rate of cooling? I would also call it as rate of cooling of sphere. We have to express it in terms of the other parameters. The energy balance says that because it is losing heat by convection and radiation, the rate of total heat transfer from sphere to ambient is equal to the rate of decrease of internal energy of sphere with respect to time. What is the rate of total heat loss? Loss by convection plus loss by heat loss by radiation. The rate of heat exchange by radiation plus rate of heat transfer by convection should be equal to the minus mc dt by dt. What is that rate of heat transfer by convection? We know that Newton's law of cooling, that is H A, temperature of the sphere at any instant of time, minus temperature of the ambient. This is a Newton's law of cooling, plus what is the rate of heat exchange by radiation? We can consider the sphere shape factor with respect to the ambient is 1, but the other shape factor is less than 1. A one body is enclosed in an enclosure, therefore we can use epsilon of the sphere, sigma temperature of the sphere to the power of 4 minus temperature of the ambient to the power of 4 into A. This is the radiation heat exchange. What is that mass? Density into volume. C is the specific heat, dt by dt. Therefore, from this dt by dt can be obtained as that minus sign only shows that the temperature of the body is decreasing with respect to the time because of this heat loss. Mass of the sphere is substituted as density into volume plus epsilon into sigma into in fact in this particular things, area of the sphere is taken as 4 pi r square, that is 4 pi into d by 2 whole square, and volume of the sphere is 4/3 pi r cube, that is r is d by 2 whole cube. So you can take the volume of the sphere as 4/3 pi r square and area of the sphere as 4 pi r square. If you substitute these values there, you may be getting this answer.